respiration. So anaerobic respiration, probably physio, you don't really, I would assume you probably don't really mention too much about, because in our bodies, a lot of animals, it's always aerobic. Like usually it's aerobic respiration. Bacteria, though, are way more versatile than we are, so they don't have to rely on oxygen like in order to survive and make their ATP. So anaerobic respiration is like another option. And the only thing that we're going to add, and then I'll draw this out, is respiration, it's a pathway. It's a series of many chemical steps, enzymatic steps that go back to back to back to back. And depending on how physio went, you might have memorized glycolysis, maybe, or memorized Krebs cycle. But these are processes, so it's not like a single step kind of thing. But whenever we throw out that word respiration, so it's a pathway that a lot of living organisms use to make their ATP, and it can happen anaerobically. It doesn't have to be aerobic. It doesn't have to. Now for obligate aerobes though, on the other hand, if you're an obligate aerobe, yeah. Anaerobic respiration would not be an option for you, so that's kind of out. But for a lot of the other organisms we've talked about, like facultatives, for example, they could definitely switch into this option, anaerobic respiration. So anaerobic and aerobic respiration are basically the same steps. The only difference is at the end. So there's this process called electron transport chain. At the end, all we're saying is that oxygen doesn't have to be used there at the end. So aside from oxygen, the organism could use thiosulfate, for example. So thiosulfate is one option. You guys have tested for that like a couple of times. So if they metabolize thiosulfate, they kind of make like that rotten egg smelling gas. Thiosulfate is something that you would find in the dirt, in the soil. So that's definitely one option. The other option is nitrate. And nitrate and thiosulfate, they're kind of like in the same category. So we can kind of think of them as like other options, bless you, other options other than oxygen that the bacteria can use to build their ATP. So nitrate, like where out in the real world would we find nitrate? That would also be, you'd find that in the soil. Technically, nitrate is also like in our bodies as well. So there was like a really interesting study that was done not too long ago about bacteria that use nitrate in your mouth. So they do the anaerobic respiration pathway and they just use the nitrate in your mouth, so for the oral bacteria. So this is not just something that bacteria in the soil do, they can do it in your body. Okay, so what we're going to do is we're going to shift our focus from thiosulfate to nitrate. That's all we're going to do. And we're going to very quickly put this into context, just so you get an idea. So we'll draw some dirt down here, and draw like a cow up here, which doesn't look right, but is happy, I guess. So we'll draw some manure over here. And what else? Dying plants. So in the soil, right? There's fecal matter, definitely. Something's wrong with that cow. There's fecal matter. There's like plants that are dying. Either way, so the manure, any like organic material they can definitely be a source of, not nitrate, but they can be a source of ammonium. So NH4 plus is ammonium. And what can happen is there are some bacteria that like live in the dirt where they can actually use that ammonium. Like they can metabolize it. So there's some bacteria, they might metabolize that ammonium. They might metabolize that ammonium and actually convert it over into what we call nitrate. So nitrate is represented as NO3. And so nitrate is actually something that you can find in the soil. Then there are definitely, I'm going to write other bacteria. Instead of metabolizing ammonium, they can metabolize the nitrate. So they can metabolize the nitrate. These other bacteria that I kind of have mentioned off to the side, they're also in the soil as well. And so what we're going to focus on is kind of this part of it, this part of the picture. So there's different outcomes that can happen when they metabolize the nitrate. Definitely one of the outcomes though is they can actually release a gas called nitrogen gas. So at least there's kind of like that piece in common. We have the thiosulfate hydrogen sulfide gas, we have the nitrate and the nitrogen gas, so kind of similar idea. So nitrogen gas can be like one of the outcomes when they metabolize nitrate. And then to complete our loop, we're not going to focus on it in this lab, but what ends up happening is there are plants called legumes. Legumes would be like the type of plants that produce beans, like soybeans, for example. And farmers actually like having legumes around. The reason why is because they have these big old pods in their roots. So their roots like don't look normal. So they're like these thick pods, and basically who lives in those pods are bacteria. So the bacteria basically kind of hang out in there. And the way this works is instead of eating, like we keep saying, peptone, amino acids, what they will use for their nitrogen is the nitrogen gas. So these bacteria way over here that are hanging out in those pods of those legumes, they'll actually just grab the nitrogen gas from the air and use that instead of like amino acids, because nitrogen gas has nitrogen in it, so they'll just kind of metabolize that. And what's kind of cool is when they metabolize, let me continue this way. When they metabolize the nitrogen gas, they'll actually make ammonium. They'll make ammonium. So the bacteria that are hanging out in the pods, they'll actually produce ammonium in the soil, which is kind of our starting point again. And ammonium is great because ammonium is basically like a fertilizer. So plants are like really happy to have ammonium around. So those legumes and those bacteria, they have like a very symbiotic relationship. The legumes like to have the bacteria around in their roots because they're basically producing all this plant food for them, a bunch of ammonium. So anyways, we kind of have this cycle. We have like bacteria in the plant, we got bacteria in the soil. They're all metabolizing different pieces, the ammonium, the nitrate, the nitrogen gas. But what we're going to focus on is this side. So we're going to focus on what's going on over here on the right. We're going to option. We're going to write on the board right now. It's called nitrite.
Oh,
Yeah. I didn't say, so Claire, I didn't say it. Yeah.
you said legumes?
Oh, legume, sorry. Legume, but it's like, at this angle, it's hard to see. L-E-G-U-M-E-S. Yeah, that's kind of hard from that angle, probably, to read my writing. Okay, so we're gonna focus on this side of the piece, but the reason why I do the picture is because the bacteria that metabolize nitrate, they can actually make a gas that other bacteria use, so everything's kind of interconnected. So the lab that you guys are gonna do, let's see, the media that you used was called a nitrate broth. And maybe the one nice thing about this lab is we don't really have to talk about the media at all because there's not really a whole lot in it. So there was like a liquid broth that you guys inoculated. And as far as what is in there, it's just two things. Here we go. Maybe it's just the peptone. Oh yeah, so we have a beef extract. There's peptone. And then there's nitrate, and that's it. So the ingredient list is pretty skimpy, and that's intentional. So we're hoping that your organisms will metabolize the nitrate and use it up. So, all right, so it is a little confusing because we have a Durham tube in there, and we've done it so many times where, actually we've done it twice, where we have a broth and a Durham tube, and usually the Durham tube is for fermentation. But for this lab, what gas are we going to try to catch here? The nitrogen gas, right? So the Durham tube has it's not connected to fermentation. We're going to use it to trap any nitrogen gas, right? So, and nitrogen gas is definitely one outcome that can happen when they utilize the nitrate. So, all right, so for our readout, we're going to break it up into two parts. So part one is actually pretty easy. Part one, you guys are going to test for single step nitrate reduction. All right, so what does that mean? So, so the single step is nice because it's just one step. So basically what we're going to do is you guys have NO3 is the molecular formula for nitrate. There is nitrate floating around in your broth, and we're just going to see if your organisms can metabolize it. But we're going to see if they can metabolize it in one step. So I just have one arrow. In order to metabolize it in one step, though, they have to have an enzyme called nitrate reductase, which kind of sounds a little bit close to thiosulfate reductase, so it's the same idea. So we have nitrate reductase, we have thiosulfate reductase. So this is an enzyme that they have to have to metabolize nitrate. And that would happen during anaerobic respiration. Not aerobic respiration, anaerobic. Because basically what the organism would do is it would swap out nitrate for oxygen. So it would forget using the oxygen, it would use nitrate instead. But in order to be positive though, it has to have this enzyme though. So nitrate reductase is not something that like all bacteria have. So, all right, so hopefully they do that and we'll end up with our end products. So what the enzyme will do is we actually don't get nitrogen gas quite yet. we end up with an end product called NO2, and it's not a gas, it's called nitrite. So single step just means they literally metabolize it in one step, and that's it, just that one step. So that's our end product. So the first part will be pretty straightforward. All you guys are going to do is you're going to sprinkle in a couple chemicals. We do not need to know the names of these chemicals because that's not really important. What's important is more like what they do. So we're going to know them as A and B. And in the cabinet, one is labeled A. It says like NO3A on the label. And NO3A is basically going to bind to the end product. So it'll tag your NO2 end product. So, all right. So it's basically like this acidic chemical, and it'll label the end product for us. So that's what we want. And then there's another chemical you guys are going to sprinkle in, and we're just going to know it as B. Because it's this chemical, like this crazy long name. But what B is going to do is B is going to catalyze our color change so that you can see some color. So the most important piece is that A and B together, they're basically going to label our end product and give us some color so that you guys can see it. Because you notice in our media broth, there's not really a whole lot in there, just some beef and nitrate, so we need a little help with the color part. So once you sprinkle those in there, we're hoping to see a nice, pretty red develop from all of this. So if you add in your A and your B, you get kind of like that red, and the red develops pretty fast, so hopefully the red kicks in. If you see the red, then you can say, yes, I am positive for a single step. We call it nitrate reduction, but nitrate reduction is just a fancy way of saying that they metabolize the nitrate. So, but it's positive. It's a positive reaction. So, and that's it for that part. So, are there any questions about that end of it? So that part will be a little bit more straightforward. And then what we're going to do is we'll diagram. All right. The second part. All right. So the first part's pretty straightforward, hopefully. The second part, though, we're going to do a little diagram to help us keep this straight. So let's see. So the first part we said is single step. The single step test. All right, we're going to do that first, and then we're going to have a split here. All right, so you guys are going to do that part first. We have two options, right? You can either get the red, just like we talked about. So you can sprinkle in the A and the B, get the red, right? And say, yes, I'm positive. I'm positive for a single step, right? So that's definitely one option. Now, so if you end up that direction, you end up with the red, then it's a done deal. You're pretty much done. So you already have your results. There's really nothing else for you to do at that point. It's like, I'm positive for a single step, right? The other option, though, is you could be negative. So you could have clear, no color, and be negative for a single step, right? That's definitely one option. So the only thing is if you land over on the clear side, we still have one other option, which brings us to the second part of the test. So for this lab, it's kind of like a part 1 and a part 2. So if you land on the negative side, then you would continue with with part 2, but if you end up on the red side, you're basically done, right? So on the negative side, we have one other option. It's called denitrification. So you could either be positive, and we're going to break this down, or negative for denitrification. All right. Denitrification is basically when the bacteria also metabolize nitrate. It's just a slightly different way. That's all it is. So we're going to talk about this part of the test right now. So we kind of have like a part 1 and a part 2. All right. So let's draw out part 2. Okay. All right, so only if you're on this side would you bother doing the part 2. So the part 2, we call it the denitrification test. All right, denitrification is kind of just a fancy lingo for saying that your bacteria also metabolized nitrate, just in a slightly different way. It's not in a single step, it's over multiple steps. This is a little bit more, I would say, a little bit more narrow, so not too many bacteria can do denitrification. Many bacteria can do single step, but denitrification is a little bit more of a specific thing. So, so on this part of the test, it actually starts off the same way. We're going to see if your organisms, it's all about the nitrate still. So we haven't really, that part doesn't change. So nitrate over here, nitrate over here. We're going to see if they can metabolize it. So the beginning kind of looks the same. Nitrate reductase to NO2. The only difference is that the bacteria doesn't just stop there. They keep going. So they would have to have extra enzymes. And I'm not going to write the names of the enzymes because that's not really important, but they kind of keep going. They keep metabolizing, and then you end up with nitrogen gas. So the beginning kind of looks familiar, but the important thing is that our end product is completely different because you end up with nitrogen gas. So, so NO2, this is representing nitrite. NO is representing nitric oxide. And N2O is nitrous oxide. And I mentioned, so technically, over each arrow, there'd be a different enzyme, which we don't have to know. But we arrived to the gas, right? So we do have the Durham tube to help us out, right? Durham, we have the Durham tube. So we can look in the Durham tube and that'll give us a clue that we're probably going on that pathway instead of this pathway, right? But the other thing though is we're going to add one more chemical just to confirm if they're doing the denitrification. What's a little confusing though is when we layer in the chemical, it's going to be in addition to these two chemicals. So over here, basically your A and your B, they're actually still in your broth. So what makes it a little confusing is that we're gonna add a third chemical in addition to A and B. So basically what we've done is we've added A and B and we got clear, right? We got clear. Then we're gonna add one more chemical. So the last chemical that we're gonna add is it's called zinc. And you guys will see it, it's like this powder. We're gonna sprinkle it in there. So here's the most confusing part of the lab. So what the zinc is gonna do is the zinc is going to force the reduction of unused NO3 into NO2. So let me clarify what that means exactly. Let me squeeze it in over on this side. Do you guys have this down already? The single step part? Okay, I don't want to like erase it. All right, so let me clarify what that means, what the two options are. All right. Okay, so probably the most important word is this word, unused. All right, we're gonna kind of focus on that word. Okay, so we basically have like two different things that can happen. So, all right, so let's say we have our zinc, and let's say you guys add it in there. All right, so we have two options. One option is you add your zinc, and the zinc does what we want it to do. So we add the zinc, and the zinc does it. It'll react with the unused NO3. Okay, and I'm going to stop here because the reason why it's unused NO3 is because that is basically implying that your bacteria did not metabolize it. So your organism did not metabolize. It didn't do. So if your organism is negative for denitrification, like negative, it doesn't do that pathway that we have written down on the board. When you add the zinc will react. Because zinc's job is to react with any NO3 that is not used by your organism. So if your organism doesn't do that pathway, doesn't touch the NO3, then when you sprinkle in the zinc will do what it's supposed to do. It'll react with it. It'll basically force it to become NO2. That's what the zinc will do. And that's what we want. And then remember, you already have A and B in there. The A, the B, that's still floating around in there. So A and B will do their thing. They'll kind of react with the end product there, and you'll get red. So what's confusing about that is that red is actually negative for denitrification. So the reason why you got color is because zinc did its reaction, but the only reason why zinc was able to react is because your organism didn't use the nitrate. So that's why you're getting the color change there. So the most confusing part is the fact that the colors flip-flop. Like red is positive on part 1, but negative on part 2. Let's do the other option. Let's say you add your zinc and there is no NO3 around. And the reason why it's not around is because your bacteria is positive for denitrification. So if your organism is positive for that pathway, it's going to use up all the nitrate, right? Consume it up, use it all up. There won't be any NO3 around, so that'll be absent. So when you add the zinc will do nothing. So zinc doesn't react like at all. So since zinc doesn't have anything to do, then A and B don't have anything to do, so you just get clear. Clear. You get clear results, so nothing happens, no color change, but that is telling you that you are positive for denitrification. Okay, that is the confusing part. Questions about the weird flip-flop? Because it's like red is positive, and then red is negative here. Yeah.
So when we first put A and B in there and it turns red immediately, that
Yes.
means that it's positive for a single step.
Yes, correct.
And then when we add the zinc, if it's clear, then it's positive for denitrification. But if it's red, then negative for denitrification.
Correct. Yes, yes. So that's kind of the confusing part, yeah. So the exactly clear is positive. Yes. So so the only reason why you're generating that red on part 2 is because there's lots and lots of substrate or like starting material. There's lots of starting material for your zinc to kind of react with, and it's because your bacteria like didn't touch it. So your organism is not metabolizing nitrate like at all. So the zinc has plenty to kind of work with, and then you get the red. You get the red color. So it's a little bit of a weird lab. The last thing before I give you your methods, it's a little bit weird because it's kind of like we're going to look for the gas, yes, and then we kind of have the zinc to help us with the starting material in a way. So we have the Durham tube for the end, and we have the zinc to kind of help us out with the beginning, just to kind of see if it's there. The zinc is just kind of like an extra confirmation. So if you see the gas, that's telling you you're probably going to move down here to like the clear result. So, all right. So I'm going to give you guys, yes, question.
So for the second part after we add the zinc and it turns red, are we to consider that then positive for the single step or just negative for both?
Oh, good question. Good question. So, if you even make it to part 2 and you're like doing the whole zinc thing, you will always be negative for single step.
Okay.
Yeah.
So it's just negative for everything.
Yeah, exactly. Negative for everything. Because the only reason why you're bothering to do this like zinc step is because you know you're negative for single step. Yeah.
Okay.
Yeah. So whether you're positive for denitrification, negative for denitrification, you'll definitely be negative for single step.
Okay.
Yeah, yeah. Yeah, good question. Good question. All right. So, all right, so the last part is, let me give you guys your methods. And let me, I think we're going to move things along with yeah.
What?
You're gonna add anything to it, we just add it up.
What are you talking about? This is the biochemical reaction. You already did it.
You didn't add like the NO3, NO2.
Oh, no, I guess not.
All right.
Yeah.
And then it'll be good because when you guys do it right now, you'll see when you add the chemicals and you get the red and you're like, wait a minute, it's negative. So it'll reinforce it when you guys do it. So per person, you guys need just a few quick things. You need 4 clean test tubes. And then to help like kind of cut down on the time, because in the morning we did it, but it kind of took a while. We're gonna do 4 plastic pipettes. We'll do the glass pipettes on a different lab so you can kind of practice. And then what else? Oh, and then let's see. So you need that, and then obviously you need your cultures from the incubator. Okay. So for the table, you guys are gonna grab your chemicals. So in the cabinet over there, we have NO3. We have the B over there in the cabinet. I'll walk around and give you the zinc dust. So I'll give that to you. The only reason why I hand it out is because it's actually pretty flammable stuff. So, all right. And then before I forget, we'll definitely have you guys wear gloves for this when you're adding the chemicals. All right. So your setup is actually going to be pretty straightforward. You're going to have for your setup. For your setup, you're going to have your 4 clean test tubes like this. So it's up to you on how you want to do it. If you feel like you're gonna get yourself jumbled, you can definitely write the organism names on here, or if you just wanna line them up side by side, that's fine too. So like put your negative control. So in my picture here, these are the clean test tubes that you're gonna grab from the cart that have nothing in them. So if you wanna put this next to your negative control from the incubator, and then this is like E. coli, then we need one for M, I think it was luteus, and the other one for P. aeruginosa. So you're more than welcome, you can label them with a Sharpie if you don't want to get confused, but you're going to grab your cultures from the incubator, right? So we have our test tubes that have been sitting in the incubator for 2 days. We're going to grab them, and you're going to use this to pipette like the liquid. We're gonna basically we're gonna grab like a little sample and then just dump it into the clean test tubes. We're gonna pipette 2 mLs. And 2 mLs is not a lot. You'll see when you so to kind of move us along with this are our plastic pipettes. So what you'll do is the plastic pipette, just so that you know, they are 1 ml pipettes. So kind of the best way to do this is, I forgot to tell the morning actually, it's always a good idea to first mix up like your broth. Like meaning, so just take your pipette and just kind of suck up and squirt down, suck up and squirt, it's like siphon up and down, because they've been sitting around for a while. So your organism is probably all like settled at the bottom. And then what you'll do is you'll, let's see, do they have a number at the top so that you know? Let's see. Let's see how these are. Oh yeah, okay. Yeah. All right, so there is, the way the pipette works, let's see, we got 1, 2, 3, 4. So there is, when you kind of hold it and look at it, let's see, there's like little notches on there. 1, 2, 3, 4, yeah. So there's like 1, 2, 3, 4. There's like 4 kind of like tick marks on there. It's hard, they kind of have like little notches. And right when you get to like that top notch, it's kind of like right here below like the bulb part. That'll get you your 1 ml. So you'll do that twice, times 2, if that makes sense. So you'll suction it up and then dump it out, suction it up, dump it out, and then you'll get your 2. All right, so then we'll have our 2 mLs in here, 2 mLs here, 2 mLs here, and 2 mLs here. Okay, and then once you're done with that, the rest is pretty easy. So you will go ahead and do your single step first. So for the single step part, you'll just go ahead, add 5 drops of that A chemical and mix it up. And then do 5 drops of that NO3B chemical and mix it up. So that'll be pretty easy. Now remember, you're doing this for all 4, right? So you're doing the 5-5 combo, even in your negative control. And then if you get red, you're done. Like that's it. There's nothing else you need to do. You kind of just stop there. You only go to step 5 if you are clear. So if you're clear, if you're negative for single step, then you'll bother with step 5. So step 5, all you guys are going to do is go ahead and add a little bit of zinc. If I can zoom out. Okay. So we'll add some zinc dust and just kind of mix it around. That's fine. And then again, we'll look for the red or clear option for the denitrification. So step 5 is going to help you out with the denitrification. Let's see. Oh, and then also too, I mean, if you're down here like doing the zinc step, then definitely check out your gas. So check your derm tube and see who's gassy and who's not. And I think that is it. So we need some pipettes, and we need some clean test tubes. I'm gonna have to fix this all so we can squeeze it in here. And then what I'll do is I'll go in the back room and I'll pull out your cultures. So if you guys wanna